Okay, now we are on to our next question. We are on question 5, and we're given the equation e2x plus ln k is equal to 3e to the power of x. And now we're asked to determine the range of k values such that the equation has at least one real solution, and we will express range in terms of k. So we'll take our initial equation, we'll call it star, and we are going to arrange the terms so that they are all on one side. So star then becomes e to the power of 2x plus ln k minus 3e to the power of x. And it's all equal to 0. And we're going to introduce a variable that we will call a. And we will let this be equal to e to the power of x. And we will rewrite our equation with that variable. So our equation then becomes a, squared plus ln k minus 3a, which is equal to 0. Okay, with this equation, we can use the quadratic formula to solve for our okay, so the quadratic formula looks like this here, where we have the equation ax squared plus bx plus c equal to 0. We can then solve for x using this equation here, where we substitute our values b, a, and c. Okay. And we have the equation that we are substituting above, where we have a squared minus 3a plus ln k. So our equation will become, we're actually not looking for x, we're looking for a, of course, because we've changed our variable. But a is equal to 3 plus or minus. Here, let me clarify this. So our term a will be in front of x squared, or a squared in our case. A is equal to 1, b is equal to negative 3, and c is equal to ln of k. So our equation will be, now back to our equation, we will have a is equal to 3 plus or minus the square root of b squared, which is negative 3 here, so that is 9, minus 4, and a, which is 1, and c is ln of k. All of this is under the root, and it is divided by 2a, where a is 1, so it's just all over 2. Okay, so now since we're solving for k, if we evaluate just for our discriminant here, we know that this must be non-negative, right? So we can say that it should be greater than or equal to 4, and then we can rearrange this so that we get 4, we get 9 is greater than or equal to 4 of ln k. We can rearrange this again by dividing both sides by 4. Then we get 9 over 4 is greater than or equal to ln of k. Then continuing over here, we can exponentiate both sides. So we get e to the power of 9 over 4 is greater than or equal to k. Or we can say k is greater than or equal to, less than or equal to e to the power of 9 over 4. And since it's non-negative, we know that k must be greater than or equal to 0 and less than or equal to e to the power of 9 over 4. And that will be the range for our value k.